I've recorded so far. I sometimes have to redo bits because I only realize later on. Anyway, it's now recording as far as I know. Yeah, it is. Okay, good evening, everybody, and also the online people. One, I see you on an iPhone, so can you see the screen as well or not? And maybe you can't talk, so you can always type in the chat box, I guess. And all of you, if you have questions, use the chat box. I've in the meantime learned how to use a poll, so I'll ask a question every now and again and open up a poll which you've got to answer, just to make sure I'm not the only person that's awake, Okay, so let me move you slightly out of the way, and then I'll share my screen. Okay, if you listen to the little introduction that I've given, we're obviously skipping a couple of chapters, and we're going to chapter 15 tonight, and we're looking at something called regression analysis. And partly why I wanted to get to regression analysis is because it's, on the one hand, simple, so it's not extremely complex, and we've done a big part of it already anyway, because we've done it in chapter 4. In chapter 4, you remember, if we compare two numeric variables, how do we compare it? We do what kind of graph do we use to compare two numeric values?
Bar chart?
No, sorry. Next.
Scatter chart?
No, next.
Line graph.
No, that's for time. Next. What do we do when we fit a line? So I'll give you a line, but when do we fit a line? When we do regression analysis or a scatter chart. Did somebody say scatter chart?
Yeah, I said.
Okay, then I'm wrong. Yes, it's scatter chart. Okay. I just want to make sure you know. Okay, so yeah, we did a scatter chart, and if you remember correctly, we added in Excel, they call it a trend line, but the real statistical term is actually a scatter, a regression line. Okay. At any rate, I'm sharing my screen, and here's the slides. So let's go through the slides, and then we'll work through a couple of examples, and hopefully you'll get the idea. But it's, as I said, it's a big part, a revision of what we've done already. So you don't have to be too scared about it. So first of all, we start off with a model, and then we're estimating the coefficients. And then we're going to look a little bit around error variables and assessing the model. But we're not going to focus on 15.3 or 15.4. We're going to focus on 15.5 using the regression, and not so much on 15.6 and not so much on 15.7. So the main thing we're going to look at is modeling, estimating the coefficients, and then using it. How are we using it? Does that make sense? You made note of that?
Yep.
Good. So we'll learn how to identify dependent or independent variables. We'll learn a little bit about the least square method, but more just understand what it physically looks like. You don't have to understand the mathematical formulas, but I'll try and explain it to you. And then there's certain requirements. You've come across that before. The stuff needs to be normally distributed and so on. And then you want to test the significance, and that you remember R square. That's how you do R square. How do you calculate the measures, which is the alpha and the B, A and B, so on, and then how to use it. And calculate the prediction interval. Yeah, so this sounds important, but not very. Okay, so the bottom line is if we want to analyze the relationship between two numerical variables, we want to use correlation and regression. Correlation and regression, that's the two things. We've already touched on it in chapter 4 and 5, and we now basically a little bit extended. Sometimes they talk of a dependent variable and an independent variable. And in our case, we're looking at simple linear regression. So there's only be one independent variable and one dependent. But in theory, you can have many independent variables. You remember that data set that we looked at, the Bay Coast data, and you say, what predict the price of the house? Now you can say it's the number of bathrooms, the number of bedrooms, the area of the stand, and so on. So each of those are different variables, but we're only going to look at the relationship between one of that, or two variables at a time. Okay, we employ correlation analysis, two variables. This chapter will examine two variables, and it's called simple linear regression. The word simple means there's just two variables. The word linear means it's a straight line, and regression is regression. Okay, and we're going to build a model with that. Okay, if we knew everything, if we know the whole world, we can have a deterministic model. But because we're studying statistics, we're looking at probabilistic model. Okay. A model to create we want to end up with something, for instance, y is a dependent variable, is something plus that multiply with x, which is the independent variable. And you remember in the scatter chart, this one is always the horizontal axis, and this one is always the vertical axis. And it normally looks at like something like this, a model of the relationship between house size and the house price will look something like this. And we can see here for every dollar or for every square meter that the size increase, the price will increase with $800. Can you see how I get that? If you put in a 1 here, if you put in a 0, you'll get one number, and if you put in a 1, you'll get 800 more. Do you understand that? So from 0 to 1, it will increase with 800. Does that make sense? It's a key thing that you need to understand with these modeling. Okay. Let me. Okay. One of the key conditions is that we assume that the standard variation or the variation stays the same, even if the prices change. So even though they can be different at different levels, we make an assumption and say it's the same. Okay, so how do we represent the fact that it's not the same? We add what's called an error term, an error variable. And this error variable, I'm telling you, needs to be normally distributed. So that's one of the tests that you have to check, is this normally distributed? Okay, the straight line model, they often use beta 0, beta plus the error. This is the y-intercept, and this is the slope. When we get to practical examples, I'll show you more of that. Okay, here again, beta 1 is the slope, and this is sometimes called the run and the rise. So this slope is nothing other than the rise divided by the run. So it gives you a ratio of how much this line is increasing. Can you see that if this line was perfectly horizontal, the run would be big and the rise would be 0 and the slope would be 0. So if this line is horizontal like this, this beta 1 will be 0. If, on the other hand, the line is straight up like this, then there's no relationship. Well, if it's horizontal, there's no relationship, and if it's vertical, there's no relationship. So it's got to go something like that. This beta 1 needs to have a value. Okay. Estimating the coefficients. Okay, here's where it's now getting a bit difficult. The question is, which straight line fits this data? Let me just cancel. Yeah, I'll talk to it just now. If we look at these lines, how the data points vary, we want to fit a line through here, and we need to have a measurement that says this is the best line. So we can fit it like that, or we can fit it like that, or like that. Which line is the best by some term? Well, it's called the least squares. So whatever line gives me the least squares, we'll come back to it a little bit, but you don't have to worry about it. The maths behind it is sort of complex, but not really. So let's look at our first example. Years of experience and annual bonus. And I'm going to open up an Excel spreadsheet and key that in and do it. And you can do it on your side as well. No. Let me just close this one. Okay, I'm just going to stop the share so I can open up an Excel spreadsheet. Can you? Okay. Okay. You guys can open an Excel spreadsheet so long. I don't know why it still gives me a problem to open a spreadsheet. Let's try something else. If you guys open your spreadsheets here.
Yep.
I'm still struggling, so you one up on me. Okay, there I'm starting. Come on.
Did you just want us to open a
Screen again? You opened up a plain Excel spreadsheet, did you? And then you can key in this information. Okay. I suggest that you make up a column that says years of experience and another column that says annual bonus, and then key those numbers in. I don't know what my Excel is battling here at the moment, so I don't know what the problem is. I'll close all of this. Okay, anyone that's done a scatter chart yet? Okay, I don't seem to be able to open an Excel spreadsheet. Okay, there, I just managed. just when I wanted to give up. Okay, so here's my Excel spreadsheet coming up one way. So I've got years and I've got bonus. Here's 1, 2, 3, 4, 5, 6, and there's 6, 1, 9, 5, 17, 12. You guys there?
Yep.
Did you manage the scatter chart? Highlight
No.
these two, insert, highlight these two columns like that. Go insert, and this one here. Okay, you better do a lot of these things so that it becomes truly second nature. If you see there, it didn't take me a lot of time. You see that? So how will I fit a line through these numbers that is the best? Now, because Excel can easily help me with that, I can just say add a trend line. And you remember we in simple linear regression. So the thing I want to fit is a linear thing. And I know I'm going to need this intersect, and I'm going to need this, no, not that one. I want the display of the equation, and I want the display of that. And there you can see it. So I normally move it to a space where I can easily read it. And I would generally make it bigger by clicking on this button here. Okay, the bottom line is I've now fit a line, and because of the method this line is calculated, I know this is the best line that can fit through this. How does it calculate that? It minimizes the distance between this and each of these distances between all of this. Okay, so let me draw you a line.
Why does the trend line change a little bit when you click set Y intercept?
Because you can then specify a value. So if I, for instance, click on here, I can now say set the intercept at 0. Can you see there? So it will force this line to go through the 0. But that's not, in general, you don't want to do that. It must, so in this particular case, I can see from this formula, it goes through 0.9333. And my recommendation is that you always edit this formula. And there says bonus, and there says the X value. And put in a multiplication, and that always helps you to understand what's going on. Do you agree? So we now know, based on this line, we estimate for every year that's going on, the bonus increase with 2.1. Can you see that? This total, this value here will increase with 2.1143 for every year that I increase there. For instance, if I want to now, for argument's sake, know what will 7 be, I can put that formula in there, equal 2.1143 times the year plus 0.933. So I predict it will be 15. And if I now change the data, can you see, to include that one, it will bring that point in, And can you see it brings it on exactly where that line is? There's that one that I just added. Does that make sense for you? Okay, to come back to what I wanted to say is, how do I know this is the best line? Well, take the distance this one. It takes this distance plus this distance plus this distance minus this distance I'm going to change its color minus this distance minus this distance and this one doesn't matter because it's 0 and it forces itself and says that must be 0. So if I fit a line anywhere else, if I now go and I say, nah, I think this line is a better line, and I draw a line, say like this, by definition, I know it's not, because if I calculate all these distances again, it will not be 0. Can you guys intuitively see what I'm talking about? Okay, I hope it makes sense.
So do you have to, when you write the answer, do you have to calculate those values and minus them by the other ones?
I mean, if you want to, I can prove it to you. Do you know? Can you remember Pythagoras theorem? Can you remember that? It says this distance is the square root of this distance plus this. It's the square root of this square plus that square. Can you remember that? So if I fit a triangle there, let's see. I fit a triangle there. This distance here is the square root of this square plus this square gives me that square root. Do you understand that? Okay, so let me show you. If I do the predictive bonus, and I put this formula in here, and I say equal to, okay, I've got the formula here at the end already. Control C, V, that, yeah. So in the first case, this was the actual value that I got, but I would have predicted it should have been 3. Okay. So I got 12, but my predictive line would have said, no, it must be a 13. You see where I get these points from? You know, see where I filled in this formula, 2.1143 times the year. Okay, let me zoom in. Okay, the bottom line is, this is the value that if I put in 6, I would have got 3.04, which is, okay, let's see, where's 6? Okay. I just, no, 7. Okay. Yeah. So I put in the value 1, this value here. If I go up here and go to the left, can you see that that comes up roughly at 3? You guys see that?
Yeah.
Or if I put in 5, I would go there and across. That would give me 11 something. And you can see there it's 11.5.
Mm.
Okay. At any rate, so this is the straight line predict that this must be the bonus based on the year. But this is the actual value. So the bottom line is this line fits in such a way that this distance is 0 if you add it all up. Okay, anyway, let's see if the slides explain it better. Let's go. Okay, this line minimizes the sum of the squared differences. So it minimizes that difference. In this particular case, they've drawn the differences slightly differently, and I'll go and draw it like that next time we get back to Excel. But can you see, here's the formula, and it came up with exactly the same formula, 0.934 plus 2.114 times x. Except in my case, I had these variables the other way around. These terms the other way around. Happy with that?
Yep.
Okay, let's see what they tell us now. The best line is the one that minimized the sum of squared vertical differences between the point and the line. So it says the best line is that one. So let us compare 2 lines. So there's my 1 line. And it calculates these differences, 2 minus 1. Can you see squared plus 4 minus 2 squared? Okay, so let's sum of squared differences. Can you see that this number here, that's the 2 and that's 1. The x value is 1 and the y value is 2. So it says 2 minus 1, square it. And then 4 minus 2, square it. Where did they get that 4 minus 2? This one here, 4 minus 2. Okay? 1 minus 0.5 minus 3. 1.5 minus 3. 3.2 minus 4. And they square it all. And it comes up to 6.89. Now, if we add any other line, say we add this line, which is a horizontal line. Can you see it? And we repeat those same calculations. You can see that this one is smaller. The smaller the sum of square differences, the better the fit of the line to the data. Now, I'm a bit confused now. So let me just see here, the smaller the sum. This can't be correct. This number is not, can't be correct. Can someone quickly do this on Excel? Okay. 2 minus 2.5 in brackets square plus 4 minus 2.5 square. This can't, this number needs to be smaller than that number. That's all I know. Can you guys read me those numbers? Anyone done it?
No.
Okay, so then I'll have to do it. Waste your time. Okay, so I'm first going to do the first one. 2 minus 1 to the power of 2
2
plus
4 minus 2
minus 2 to the power of 2 plus bracket 1.5
minus 3
square plus 3.2 square. I need a bracket in there. Plus, have I got all of them in?
yeah.
No, so, okay. 2 minus 1 square plus 4 minus 2 square plus 1.5 minus 3 square plus 3.2 minus 4 square. Okay, so that number of theirs looks wrong to me. That should be 7.89. So let's do the second one. And I'm just going to make a copy of this one. And it should now be simple. The second term is always 2.5.
Yeah.
Now hold 3.99. The second line should have been bigger. The smaller the sum of the squared differences, the better the fit, which means this, or if I interpret this, the horizontal line fits better, but hopefully you can see that it doesn't fit better. 7.89. You can just see that one again. 2 minus 1 squared plus 4 minus 2 squared plus 1.5 minus 3 squared plus 3.2 minus 4 squared 6.86. Okay, let's go on. I'll have to figure this out. There's something wrong. The bottom line is this line 1 in, okay, let's see what they say next. Okay, to calculate the estimates, which is just that formula that I've put in now. So they multiply that. This is using Pythagoras theorem to do this calculation. And then we end up with this value here. As I said, I'm more interested in you being able to do it in Excel than here. So don't worry yourself too much about this. Least square estimate, doing all of that. Fortunately, Excel does it all for us. Okay, so let's do this one. Example 15.3. Okay. Can you guys get the data set for 15.3 up?
Yep.
Okay, I'm just going to stop my share so I can move a bit faster. Okay, tell me when you've got your data up and see if you can fit. Do a scatter chart. Who can? I think I should leave that to you. Do a scatter chart. And then share your screens with me. How's that for a plan? Huh? No, I don't need to do nothing. Okay, so you'll have to get the data of Moodle, I guess.
Yes.
How are you doing, Sharma? Are you getting the data? I can see what you do in your glasses, you know, it reflects, so I can see you're watching some other YouTube clip there.
Mm.
So, who's got the data up? Yeah, seem to struggle with my machine. How far are you, Sharma? How far are you, Nicholas? Who's got the data up?
I've got it.
Okay, can you share your screen? There's a little green button at the bottom. Just click on it and say share screen. Okay. Did you fit the line? Yeah, I see there. Okay. What can you tell me? If do you know what an odometer is, Sharma? What's an odometer?
Is that on the car?
Yeah, this is a car. What does an odometer mean?
The distance travel.
The distance, and that makes sense. The more a car travels, the less it will be the price that you intend to pay for it, isn't it?
Yeah.
How
Yeah.
much less will the price be for every kilometer that you traveled with it? Or for every 1,000 kilometers? I think the odometer must be in thousands of kilometers. For every 1,000 kilometers you travel, how much will the price be less? For every one in terms of our graph. Do you know, Nicholas?
I'm just still in the process of downloading the Excel, but yeah.
For every one, if odometer goes up with one, and I assume it's 1,000 of kilometers, how much will the price come down? Can you see
by negative 6.97?
Well, it will come down by 6.9 because it's negative. So this particular graph shows there's a negative relationship. And can you see that the line is going from the top left down to the right?
Yeah.
Sharma, can you change the axis, the x-axis, so to start at 12?
You're hungry.
Close. This is our, yeah.
Sharma, can you change the x-axis so the minimum starts at 12? Click on the x-axis. Click on the x-axis. I guess right click or something. Yeah, no, yeah, format, no. Okay, just click on the axis. You haven't clicked on it. Try again. Click on the axis, which is, click on 16, 18, there, around there, the axis. No, lower down. Lower down. There. Whoa, just stay there.
Yeah.
On the left-hand side, there's, I think where there's little 3 pillars. Can you, on the right-hand side, can you see the little 3 bars? Click on it. Access options. And there where it says minimum, let me move this. Make that 12. Now I want you to watch the graph when you've done that. Press enter. Can you see how your graph has changed?
Yeah.
Because your x-axis now only start at 12, and you can see it's more readable. Do you agree that your graph is more readable?
Yeah, it's way easier than before.
And you might want to move that down to the bottom left. Move it to the bottom left. Yeah. So you just put it in some clean space, and now it's quite a readable graph. Okay. I'm still battling to get to the, so you win, Charlotte. You've got the data up. Okay, Nicholas, how's your data coming on?
My one's going good. Let me just bring it up in a second. I just got all these Excel files just everywhere because I was doing my assignment before this class. Sorry.
Gotcha. Share your screen. I'll now every so often say, share your screen, and I can see what you're busy with.
There you are.
Okay. You haven't put in the formula, so if you right click on your line, okay, yeah. Okay. But you can also see as the odometer number increase, the price will actually come down. Can you see the line is sloped like that?
Mm.
Okay. Harriet, you're on a phone, so you can't share your screen, is that right?
Yeah.
But can you see what the boys has done?
Yep. Hassan done the same thing.
You've done it and it looks similar?
Yep.
Okay. Okay. You guys are winning because I still couldn't get to the data yet. So how bad is that, huh? Try one more. It says cannot complete the folder extraction.
Just a quick question from the example you showed before on how you had, so on here, you know, like let's say this is the X and this is the Y, and you had like a prediction one.
Yeah. Do you want to add that?
Yeah. How would I do that again?
So key in C1 prediction or whatever. Prediction. Yeah. And just underneath there, you will fill in that formula. So under C, okay, so equal 6.9718.
Negative or just positive?
Negative, sorry. 718 times, and then click on A2. Enter. Sorry, and then just draw your graph so I can see the full formula. There's plus 149.21. Plus, no, not equal, plus 149.21. Press enter and drag that, right click in that little corner. Okay. And now, for example, if you look right at the bottom, or look at any number, for instance, 15.4, the prediction is 41.84, where the actual value was 36.4.
Mm. Yeah.
Now, if you look on the graph, where 15.4 is, and you follow up with your I, 15.4, which is roughly there, and you go across, it gives you like 42, 43. No, where you cross the line, you go to the left.
Oh, yeah.
Okay, which will give you roughly 40, 40.2, 40.3. Can you see that? No, don't click on anything. Just
Okay.
move your cursor. You go up from 14.8. Put your cursor at the bottom, 14.8, and move up, 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 and then to the left. No, to the left. Now move to the vertical axis. Your cursor, there. Now, can you, if you read it, you can see it's sort of 45.
Yeah.
And if you read in the data on the left-hand side, you can see, yep, it's the, which is the bottom one.
36.4.
Yeah. No, that's 36.4 is the actual value, but the predictive value is 41.8.
Yeah.
But that's 15.4. Okay. Anyway, you can work through. I hope you understand what I was talking about. Okay, if you stop your share, I'll share my screen again. Let's work through the slides. Okay, I think that's not a bad idea that you guys do it and share your screen. Then I know you've got it, isn't it? Okay, so that's that example. Now, this is the thing that you need to be able to do in the exam or class when you get this type of problem, okay? You don't need to understand the maths. Example 3, solution. Okay, you don't have to understand this. If you feel like understanding it, go and read it. And here it tells you how to do it. And we're going to do this one now. Let's just see which data is this. I'm just trying. Okay. Okay, 15.3. So that's great. Okay, and that's exactly what we've done. Remember? But now I want to show you how to get to this one. Okay. And I'll give you a tip. You're going to get an exam question about this. Okay, who wants to share their screen? Nicholas, we ended up with you. Sharma, share your screen. Right. Now, I'm going to talk you through how to do the actual regression analysis sort of without the graph, if I can put it that way. Okay? So what you need is click on data on top. Yeah. So what we want to do is we want to get to this data analysis on the right-hand side. Now we're busy with regression analysis. Guess which one of those you should choose?
Regression.
My goodness, you guys are sharp. Click on OK. Highlight the Y one. What happened? This.
Maybe just bring all your data up, maybe.
Oh no, it's the.
I think there was just something wrong with his screen, so don't worry.
Got the virus. Okay.
Press enter. And now the next one is the input range. Okay, can you see you've done something wrong? I've instructed you wrong. This, okay, you need to be very careful that you do it the right way around. So put, in this case, so on the Y range, which column is the Y range?
The odometer.
Yeah.
So you just have to do the other other way around.
Or just change the A's in there to B's.
Yeah.
Can you edit what's written there? That sheet 1? No. Okay. Sharma, listen carefully to me. Yeah, delete that. Delete it. And click on the right-hand side in that corner of it. On the right-hand side there, click. Now highlight that one. Are we wrong again? Press enter. Okay, just give me a moment. The price is actually the Y, isn't it?
Yeah, that's what I thought because it has Y written right next to it.
Yeah. Okay, so sorry, go and highlight. Just click on the corner in there again, to the right, to the, yeah, there. Click. But just enter. Okay, now labels is marked. Output, click on the little round circle next to output range. No, the round circle. Yeah, and now click on that one and put it there in E20, say. Click, press enter. And now at the bottom, we don't need any of that yet. So just click on OK. Okay, it shows me, I hope you can see that the graph is actually the wrong way around. I didn't spot it, but it's a good thing we spot it now. Can you, if you look at the graph, it's actually got the price at the bottom and the odometer on the left. Can you see that?
Yeah.
So we actually need it the other way around. So how are we going to delete the graph? So let's just delete the graph because it's not the right way. Or okay, right click on the graph, right click, okay, Control Z, right click on the graph. There's an option, select data. And there's sometimes an option, switch rows and columns. Can you see there? Click on OK. Oh, okay, delete the graph. Delete the graph, sorry. Okay. Now, my recommendation is that you click on C on top of the graph. C, right click, no, right on top on C. Click, click, right click, and insert. Click on A, and click where you can drag the column. No. Okay. Yeah, there. Yeah, there. To C. Yeah, that's it. Now highlight odometer and price. Click on insert. Click on your scatter chart. Click. Okay. And now right click on the chart, right click in the data. Okay, and fit the trend, add a trend line. Click on display equation, enter R, yeah. And now let's fix up. Click on the axis at the bottom and make the minimum, yeah, click, yeah, minimum, make it 15. Click on the Y axis and make the minimum 14. Right, and now you can see, if you look at that equation, you can see how it relates to what we got at the bottom. Can you see that? So the slope, which is minus 0.0937, can you see there at the bottom in G37? Put your cursor in G37. Put your cursor in G37. The block G37.
Just down. Yeah.
G37. Yeah, that one. Can you see that number is the same that you've got in your equation?
Yeah.
Yeah.
And the 19.61 is the same as in your equation.
Yep.
Can you see that? So with this analysis, we've now got the stats at the bottom. So we didn't need to draw the graph. We could have done the analysis just through the analysis and not. My recommendation is that you always draw the graph and you always do this calculation.
Quick question.
Yeah.
It says here lower 95, upper 95. There's two of them.
Yeah, the one is for the intercept, which is that for the minus 0.0937. And the
Yep.
other one is for the odometer, which is the 19.61.
Okay. And because it's lower 95 and upper 95, is that the significant level or that's the confidence level, right?
Yeah, that gives you a confidence limit. So if somebody says to you, I want to be 95% sure that these prediction calculations that you've done is right, or definitely, then you can add the same prediction calculation, but using the 95% interval. Does that make sense?
Yeah.
Okay. So one gives you, if you scroll down, let's just look at the formulas at the bottom. Yeah. So the lower and the upper, so it gives you two extra columns if you use those two values instead of the coefficients, which then can predict. You can say with 95% sure it will never be under this, and with 95% certainty it will never be above the upper 95%. Okay? But I see what you're saying, there's two values, but you can see they're the same. And you see the actual numbers is the same.
And what's that significant F?
Okay, let's take a 5-minute break. It's part of the course where we're going to look at it. Okay, let's have a 5-minute break, okay? Okay, Google, set the timer for 5 minutes. Okay, I'm back. I'm still battling a little bit to get my data set that I need open, so give me one more chance. Somehow says it can't open it, or it says it doesn't exist. So let me give you, I've got another place where I've got it. Oh, got something going now.
I just did the regression thing that we just did before the break.
Yeah.
I was just wondering if I got it right.
Okay, you want to share your screen?
Yeah.
Okay, just show me your graph. Yeah, your graph is still not right, huh?
Oh.
So you need to change, rearrange the columns so that the odometer is on the left-hand side and the Y is on the right-hand side, and then draw the graph again. So delete the graph that you've got at the moment.
Okay.
And then if you click on prediction on the C above prediction, yeah. I'm sure there's another way to do it, but this is the way I do it. Okay. And fit the line. Fit the line. Okay, you want to click on the trend line. Oh, okay. No, you're in the wrong spot. Click on there. Yeah, now, okay. Now, I think on the right-hand side, there's 3 columns, the bar chart, there. And yeah, okay.
And then just change the minimum, hey?
Yeah, you need to click on the axis. It's not there. You need to click there. Now on the right-hand side, yeah, there. Make it 15 or something, yeah. And the same goes on for the y-axis. You want to okay. I think you sort of got it. Is that right, Nicholas?
Okay. Yep. And then it was just more like this thing. Have I put in the right information? Was this the same as you, man,
Yeah.
Turner?
Yeah, it's the same. And you can check the intercept and the coefficients, these coefficients, is that the same that's in your formula there?
Yep. Yes, it is.
So that's the beauty. I wouldn't do an exam or for work or anywhere regression analysis without doing both.
Yeah.
I got for the prediction for the first value, when I did the formula, the negative 0.0937 times odometer plus 19.611, I got 16.1.
Then maybe you tick the box that says it must go through the intercept or something. You want to share your screen? Let me see. Yeah, no, it's the same. Can you see the price is 0.0937? Scroll down. And that's 0.0937, the coefficient.
Oh,
And the intercept is 19.61. Scroll down. Oh, sorry, up. Shall we see the graph? Can you see there on the graph, the price is minus 0.0937. That's exactly the same as at the bottom, plus 19.611.
Right.
If you scroll down, can you see R square? Can you see, can you see R square a little bit up? R square is 0.65 on the graph, and there's also 0.65. Can you see the two is the same?
Yeah.
Yeah. Okay. So you need to, so you know you're right because you've actually done it two ways and you got the same result.
Did you get the same, Nick? For the first prediction value up here?
Nicholas?
Yeah, sorry, I just had my mic muted. Sorry. Prediction value.
Yeah, did you get that same value?
No, no, I didn't actually. Let me share my. No, you're sharing screen.
Yeah.
What did you get?
I got 37.6612.
No, yours is not correct then.
Is your formula like this?
Oh wait, no, it's because I've entered a different formula. Hang on, it's because I entered the one that I did before, which was wrong.
Yeah.
Oh, okay. Oh,
Yeah. So
okay, yeah, because that's what I was confused because I thought I did it wrong. That's why I was a bit concerned. I was checking over.
Okay. Thanks for picking that up.
Cool. All right.
Okay, so let's go back to the slides. We might have to do everything like this. I can't get the Excel stuff to open, so. But it's not a bad method for me. Then I know you guys got it.
Yeah. I think it's good because it helps if we're stuck.
And if both do it, you can compare against yourself. And here you can see is the actual results in the slides, and it's the same as what we've got, isn't it? Okay, so there they've just gone through the process now. And you can see they call it the intercept, the first one, the beta 0 estimate is an intercept. And the other one they call the slope. So you need to remember that, intercept and slope.
Are you supposed to do screen sharing? Because we can't see anything.
Thank you. I'm supposed to screen share. There. Here you can see they talk of intercept. What does it mean? It means if you extrapolated this backwards until 0 on the x-axis, it would have crossed this vertical line at 19.611. Do you understand that? So if you extrapolated this line backwards, so this value is 0, this value would have been 19.611.
Yeah.
And it makes sense because if you replace this x with 0, then you get 19.611. So that is why they call it the intercept. It's where it intercepts with the 0 on the x-axis, or intercept with the y-axis. Okay? And this one is called the slope because it tells you for every one that this increase, how much this will decrease, the total will decrease. And you always need to, if I say to you, discuss what you've seen, that's what I expect in the discussion. Okay. Okay. Now, in the generic formula, it's always y equals, what do we call this term?
Beta.
And what's another word for it? The intercept. Plus beta 1, what do we otherwise call it? The slope. But as you can see, it didn't fit exactly our straight line. So you add something called an error. And yeah, the mean of E is always 0. Why? Because that's how we planned that line. We planned it so that that difference is 0. We assume that the standard deviation is always constant for all values of X, that the errors are independent, so the one doesn't depend on the other one. The errors are independent of the independent variable. And yeah, the probability distribution of E is normal. So we assume it's a nice normally distributed thing that's around it. Let me just switch on my video. Otherwise you can't see my hand movements, you know, it's important. There. Okay. Right, so we assume that it's sort of a standard deviation. You guys now know what a standard deviation looks like. Assessing the model, the least square method will produce a regression line, and in the end you come up with a coefficient of determination, which is R squared. How good do we know is this model? Hi Vish, welcome. We look at this R2 square value. If it's close to 1 or minus 1, which is close, I mean bigger than 0.5 or bigger than or less than minus 0.5, then we say it's a relatively good fit. Okay. Sum of squares error, so there's some calculations which you guys can look at when you want to. Standard error for estimate. Okay, and here it just says, in other words, what I said. If this standard deviation or this R is small, close to 0, the model fits the data well. You can use as a measure of suitability of the linear model, which is the R square. Okay. Now it asks you to calculate the standard error of the estimate for example 3 and describe what it tells you about. So can you guys look at the Excel that you've done, and can you see this thing that says standard error, and is it 0.5848 on your Excel spreadsheet?
I got 0.4525.
Yeah, which is this one at the bottom. Yeah, standard error. You see there?
Yeah.
Do you see these numbers anywhere? 0.58 and 20 in the top part of the calculations. No, okay. You don't have to worry about it. You only have to worry about R square. What is your R square? It's the second or third one from the top on the
0.65.
Okay.
Yeah, I got that
That's the only thing you really have to worry about. Okay. And here's where the calculations is. So yeah, R square is 0.6533 is your R square. You don't have to worry too much about the rest. So the question is, what is a small R square and what is a large R square? And I've actually already told you. A small indicates a good fit. How small is small? We judge the value of the estimated error by comparing it to the values of the dependent variable, y, or more specifically to the mean. And in this example, the S is small, only 2.8 of that relative to that. And S cannot be used alone as an absolute measure of the model's utility, but can be used to compare models. So if you have more than one model, you can compare it using the standard deviation of the error. If there's no linear relationship, then the slope will be 0. In other words, the line will be horizontal. Okay, now they're going into hypothesis testing. We won't do that for here, but you understand how hypothesis testing works. If we want to test, or no, okay, let's go through this. We want to see if there's a linear relationship. We want to see if the slope is something other than 0. Remember, slope? If the slope is 0, then the line will be horizontal. So how do we check? We use hypothesis testing. The alternative is B1 is not 0. The null hypothesis is B1 is 0. Okay. So I'm going to calculate this test now using the calculations that we've got. Okay. And look at the results that you got. Okay, let's see. In terms of the example, can you see this t value? You can see here's the t stat in your example. Can you see it on your graph? T stat. And the p-value. So the p-value, if it's less than 0.05, we know on a 5%, we're 95% sure that that relationship is there. Do you understand how that works? So here's the p-value, just with the previous hypothesis testing as well. And here's the t-stat. So let's go one up. T is 13.59. Comparing the decision rule with a calculated t-value, we reject this hypothesis 0 and conclude that the odometer readers do affect the sale price. So we've got a decision rule that says reject this if it's bigger than 1.984. And we calculate it. Can you see the absolute value of t? What is the absolute value of a number? If it's negative, it's positive. So that's what these two lines means, the absolute value. So this becomes 13.59, and it is bigger than 1.984. So therefore we reject it. Do you understand how this works?
Mm-hmm.
And you should see it on your data there. So don't worry too much about all this calculations, but make sure you can do it in Excel and make sure you can do the hypothesis testing. You don't have to do any of the calculations. It's all done in Excel for you. So you just need to be able to read these values and know how to interpret it. Okay. So which one is the slope? It's this one is the slope. We look here at the t-stat. And it's, yeah. Okay. T-value and the p-value is what we use. Looking at the p-value, we conclude that there is overwhelming evidence to infer that the odometer reading affects the auction. Why? Because what does this 284E minus 24 mean? Can anyone tell me? This E means there's 24 zeros before this number. So it's 0.00000000024 and then 284. So this is close to 0 as you can get. This means there's 90 zeros before you get 754. So it's 0.00000 till you get to 90, 754. So this is as close to 0 as you can get, and this is close to 0, but it's definitely less than 0.05, which means the probability, that's the interpretation, the probability that we got this result while this odometer value is 0 is very, very small. Okay. Now we're getting to the coefficient of determination. This test thus far are used to conclude whether a linear positive or negative relationship exists. What we want to measure is the strength of that relationship. And we do this calculation with R2, R squared. You don't need to do it because Excel is doing it. And they're doing it manually here. You don't have to worry about. But you come up with 0.6533. Can you see this one in your results in Excel? R squared. It's the second, third one from the top. And it's 0.653. How do we interpret that? I've already told you, I'll tell you again. If it's bigger than 0.5 or less than minus 0.5, you say there's a strongish relationship. If it's between minus 0.5 and plus 0.5, then you say there's a weak relationship. Okay, I'm sure they're going to spell it out for us. Yeah, therefore 65% of the variation in the selling price is explained by the variation in the odometer read. Only 35% is explained by the model. How do I interpret that? 65% is explained by, of the variation in the selling price explained by the odometer, and only 35% is not explained by. Do you understand that?
Yeah.
It's pretty cool, I think. From the regression output, we've got this. So, yep, that's where you see it. You don't have to worry yourself about the adjusted error or the standard error observations. It's just to make sure you've got all the data in.
Hey, just got a question. If we were asked in an exam to do this,
yeah,
let's say that it was 10 marks for this one question. How much, like, explaining the answer, like 65% is that, how many marks would that be? Where's the majority of the marks?
It's actually in the explaining, Nicholas. I want to understand whether you can get the insight out of it.
Yeah.
The mechanics of doing it, you have to admit, I can probably teach a grade 5 child to do it, to mechanically do it, but can they actually understand what they get?
Yeah. And
that's where you come in. The two things, here's the two key things that you need to be able to understand. The beta 0 and beta 1, which is the one is the slope. What is the other one is the intercept. You need to be able to tell me, if I say to you, what is the intercept? You need to say to me, that's where it cuts on the y-axis or on the x is equals 0 axis. If x equals 0, that's where it will, that's the value.
Yeah.
What is the slope? It explains to me how for every increase in this particular case, the odometer make of 1, it will increase by whatever that slope amount is. Okay? The second thing is, how strong is the relationship? If I ask you, how strong is the relationship? You need to tell me this. You can say, based on the R squared, 65% is explained by the odometer reading, and only 35 is, we don't know what the explanation is.
Okay.
Okay, then it explains a little bit more about all these things. You don't have to worry about this if you read it for background knowledge. Now we get to, and some of this we've done already. We now know we fitted a model. We know the model fits reasonably well, and so on. So we now need to use the regression equation. Predict the selling price of a 3-year-old Ford Laser. So here's coming in prediction. So I'm asking you the selling price with 40,000 kilometers. Now, look on your Excel spreadsheet. Who wants to share the Excel spreadsheet with me? I'll nominate Nicholas.
I just need you to stop sharing because I can't.
Ah, okay, sure. Now, if you go to the bottom of your data, yeah, and add in 102, add 40, what's it, 40, yeah, 40,000 K. So I'm telling you, I've got a car with 40,000. What is the predicted price? Can you see it's 15.863?
Mm.
So if I say to you, I've got a car with 20,000 Ks on, what's the predicted price? Just key in 2020 there. Quatois, 17,000. Can you see?
Yep.
That's how this predictive modeling works. So let's, can you see that it's actually pretty cool?
Yeah.
Okay, so okay, so yeah, 15.862. So that's how we use that. Okay, if you stop sharing, I'll share my screen again, and then we go through the theory. Okay, there it just confirms exactly what you got. Okay.
Are you screen sharing?
Not yet, obviously. Just trying to keep you guys in suspense. Okay, there you can see it's exactly what you got in your Excel. Sharma, did you get that in Excel? Did you get this 15,000, Sharma? You're muted. Did you get this 15,000? Did you add at the bottom of the data 40,000 and drag the prediction down?
Yeah, I got it. Yeah, 15.863.
Yeah.
That's what I got.
That's fine. Now here's where it's coming in, predicting the interval and confidence interval. So that prediction that we've just had of 15, now somebody says to me, but hang on, I want to be 95% sure I don't pay too little or too much for this car. How can you give me a 95% confidence interval? And here's the maths. But fortunately for us, Excel is doing it all for us. Okay, can you share your screen, Sharma? Sorry, I got it on share, I guess. There. Okay, go to the bottom. Okay, can you see where that 40 is? Now I want you to put your cursor in E102, or no, E101. E101, and put UCL, upper confidence limit, and in F101 put lower confidence LCL. So in E102 we now want to do a calculation. Then the calculation is equal the kilometers, which is 40 plus no, sorry, times, multiply, and go to your calculations, scroll up to your calculations. Yeah, no, down, times odometer, that minus 0.09. click on G37. Yeah. Okay, stop. Just stay there. Plus G36. G36. Okay. And don't move. Just click and stay there. But we want to do the upper one. So drag that blue one. Click on the blue. No, that 19.61. Click on it. And drag. Can you drag it? Yeah. Drag that to upper. Can you see upper 95? Yeah. And drag the red one onto the upper 95. Click enter. Now, so that tells me I estimate the value at 15.863, but my upper limit is 16. It will 95% certainty not be bigger than 16.911. Now we're going to do the same for LCL. Okay, click equal 40 times, scroll up. And now we want to do lower 95, that one, plus, no, sorry, times the, no, times the one below that, times K37, that one, plus,
The one above.
yeah, plus the one above it. Press enter. So we know it's between 14.8 and 16.9 with 95% certainty. Nicholas, can you see how that works?
Yeah, just from that number, the kilometer,
Yeah.
to
So
the
that's how you use that upper and lower 95% limits.
Yep.
So let's see. Okay, stop. I'll share my screen now. Okay, so let's see. The lower and upper limits is 15.758 and 15.968. Is that what you guys got?
Have a look.
Is that what we got in the calculations now? Sharma, in our calculations on your spreadsheet now, did you get the 15.758 and the 15.968?
For the upper and lower
Yeah.
on 40.
Oh, yeah, you did it for 40. So instead of 40, yeah, on 40, it should have been on 40, yeah.
I got 16.9 for upper and 14.8 for lower.
Okay. So where did we go wrong? Okay, I'll have to work through.
You said upper was the 40 times the odometer upper 95% plus the intercept upper 95% for the upper, and I got 16.91 for that.
Okay, I personally think they're wrong, but let's see. Okay, let's use to estimate the mean value. Okay, they're talking here about a prediction and a confident. Maybe, let's just see, maybe they've done a different, oh, yeah, we've got it. predict the selling price between 14.958 and 16. That's the value you've got.
Yep, that's us.
Yeah, okay, so that's to predict the sell of a single car. Okay, then if you want to
Wait,
predict,
sorry. Slightly different a number, not exactly the same.
yeah, but within what?
That we're in the 14,000 and the 16,000 region.
Yeah. Okay. Trust me, that's how you've got to do the calculation.
Yep.
Okay. Then they work, if you want to predict a lot of 250, you need to adjust the formula because you now want to talk on the average. And you know, when we do an average, we always, you don't have to worry about this one.
Yeah.
And they explain what's the difference. You can have a look at that. And here they go through the exercise that we've went through. Okay. I don't think we've got this actual option. Okay. Okay, so there's the new version of Excel haven't got this option, so don't worry about it. The coefficient of correlation, we don't have to worry too much about it. Let's just see. Okay, here we come back to hypothesis testing. Don't worry about it. Okay. Okay, let me just have a look at my slides. That's the only aspects that we're going to do. And we don't need to worry about this. No worries. No worries, no worries, no worries. Okay, I'm going to, okay, I'm gonna unshare so long. Okay, what I want one of you to share, and I'll just show you some of the other options. Remember, one thing we said, the errors need to be normally distributed. So sometimes you need to at least check that. So who wants to share the screen? Okay, somebody shared. Now let's go back and go to data analysis and redo the regression analysis. Data on top. Click on regression. Now tick at the bottom. It says residuals. So click on residuals and residual plot and line fit plot. And click on normal probability plots. Let me just see. Okay, click on OK. Click on OK. Okay, now scroll down. Now you can see it did all those predicted values for you there. So you didn't need to put in if you want to check the predicted observation, 37.663, go on top of your data. Is it 36.663? Can you scroll up to the top? No, where are you now? Okay. Okay, 16.106. Okay. Scroll down again. There's something wrong. These predictions should be the same as our predictions. So scroll down to the bottom. Okay, observation 137.663. Oh, okay. I think we've put the things in the wrong order. Can you go into your... Can you see what I'm talking about? We predicted the odometer. We should have predicted the price. Yeah. Okay. Now remember the top prediction was 16.25. Let's go. And you see there your predicted price is 16.106, but close. Yeah. And let's look at the last one. Last one is 16.2. Let's go and look at your last one. 16.2. Do you understand how this works? Okay, now let's look at the plots. So take that one. This is the residual plot. Okay, if you make this graph bigger, okay, this test, okay, can you make the, click on the x-axis and make, yeah, make the minimum 14. So here you can see that the residuals is slightly increasing as the price gets higher. Can you see that? So it doesn't entirely, we expected a cloud that stays the same. But it's still okay. If it's really bad, you would have seen it. Okay, go scroll down. How come this is the wrong way around again? Can you see odometers on the left and prices on the right? It doesn't look right to me. Price, that one, I just don't understand why price is at the bottom.
I think it's because he did it twice, and those other ones are still left over from.
Oh, the wrong one is still there. That's the bad one. Now you can see that's exactly like our graph. Can you see that? That's like our graph. The odometer predicts the price, and if you change that, it will look exactly like our graph. So by clicking that buttons, we could get our graph, which again, check, yep, we've done the right thing. Our graph is just nicer, but there it is. Can you see that? Nicholas, can you see it? Can you see what I see?
Oh, yes, yes. I just had my mic on mute the whole time. Sorry, I was talking to myself.
Yeah, and can you see the graph just underneath it? Odometer residual plot. That one is now right. As I said to you, I expected a cloud that just sort of continue all along.
Yeah.
Yeah, there's nothing, there's no patterns or stuff that we can see. Okay,
No, yeah.
scroll down, let's look at the last one. The normal probability plot. This checks for normality, and that line we expect it to be like that. It's if you change the y-axis to the minimum value is at 14 again. You'll see it forms like a little S. Can you see it's a slight S?
Yeah.
That tells me this is a normal, the errors is normal. So that is how you use the rest of the stats and calculations that's done automatically for you by Excel.
Yeah.
So if the normal probability plot, if it's, did you say if it's shaped like an S, that means that that's normal?
If it's shaped like this, it's normal.
Okay. So just going up.
Yeah. This is a cumulative normal plot, if I can call it that way. Let me think. I mean, what we could do, I'm just thinking. Okay, you don't have to worry about it. There's no question like that in the exam. But I'm just telling you, if you've got to do the job at work, this is the way that you check for normality. Okay. Okay. Let's. Okay, let's stop sharing. Okay. Use Excel to obtain the standardized residual histogram. Examine the histogram. Okay. We're not going to look at that now. Yes, when we plotted the residuals, we don't want it to go wider and wider like this. That's not correct. And we don't want it to be sloped like that. That's not correct either. Now, in our data, it wasn't like that. So we're happy with how it is. So it needs to look like this. And this is what ours look like. Okay. Don't worry about this. We're not too, you can read about it, but we're not too concerned about it. Okay, summary of this technique. We want to analyze the relationship between two variables. It's numeric. We do a simple linear regression. We won't in this course do the nominal example. We only, because this is our last lecture, remember? Next week, we're just going to review everything.
Oh, wow. Damn.
Yeah.
It's gone so quick, semester one.
Oh, mate, you make my day saying that. Remember that I give you some extra marks, okay?
Yeah, I probably need it.
Somebody needs it.
Do you have time just for a question regarding the assignment?
Yeah. You've got a question regarding the assignment? I'm listening.
Yeah, question 2.
Yeah.
I've actually was just, I guess, obviously you can't tell me the answer, but I just needed guidance. It says, your client wants to know which company has the lower mean, officers per crew. Why does he want the statistics? Other information suggests that company B might have the high mean. Test this hypothesis, test at 5% level of significance. Say your analysis for this fully. And this is what we learned last week, right?
Yeah, I've done plenty of examples with that, I think.
Yeah, it was more like
comparing two populations, hypothesis testing. Or it's also called a t-test. So you want to test whether the average of the one is the same as the average of the other one.
Oh, yeah. Okay. Yeah. But the thing is, didn't we do last week with the t-test, we were the question said the mean, as in like let's say like this population's mean is 20. Can you find using the hypothesis test if it is 20?
Okay, so it's chapter 13 if you want to go and look. It will show you there exactly what you need to do. So yeah, the assignment is a little bit of self-study as well. So it's chapter 13.
Yeah.
But you'll see it's extremely similar to chapter 12, but it's comparing two populations. And it's the same, the whole idea of inference is, in this particular case, you've got two populations. So let me see if there's a clear example. I'll give you even better direction. Okay. Yeah. If you look at example 13.3, it's sort of virtually the same. Just obviously got different numbers. And also 13.2.
Does it have similar Excel sheets in that week too?
Yeah.
So, thank you.
I'm sure if you can also Google 2 sample t-test and you'll get good examples.
Yeah.
But that is there is an aspect in the assignment. That's why it's an assignment. A little bit of self-study, but I don't think it's too onerous. Happy with
There's
that?
a lot of information out there for Excel on YouTube.
Yeah. Yeah, I know this particular assignment is not on Google, so you can try and find it. But some of the another college where I teach, the assignments actually is on Moodle, on Google. So if students are clever, they'll just Google the answer. But this particular one is one that I set up, so it's not there. Okay. I think we need to, let's take a 5-minute break. And when I come back, I'll spend some time trying to get a data set up. And I think let's look at let's just do 1 or 2 of these together. Let's do 15.15.15 together when I come back. Okay.
What, 15.15.15?
Yeah.
Is this an example or is it one of the questions in our books?
The data is XR 1515.
Okay.
And it's on page 626 in that book.
Okay, thank you.
I'll, in the meantime, try and get my data together.
Yeah.
Okay, shall we continue in the last stretch?
Yes.
Okay, this looks nice and easy. So we're looking at XR 1516. Is that okay? Is that the one I said?
Yep.
I hope so, because that's the one I got open.
Good.
Okay, so here's a very simple one. They say to determine the number of housing starts is affected by mortgage rates. And it can, yeah. So this X is interest rate. Interest rate. And that's our X variable, and our Y variable is housing starts. So always try and understand what they're talking about. And so what it says, just intuitively, the higher interest rates are, one would expect less people will buy houses, isn't it?
Yeah.
So let's see. So we're expecting a negative relationship here, isn't it? So let's see. Very quickly insert. Honestly, go and do enough examples so that you can do this, say, as quickly as I can. Right click, trend line. Come on, linear. I don't want to remember. If you set the intercept, it will be wrong. You do realize that. So you should never, in my humble view, ever click that one.
Francois, isn't this question 3?
This is XR 1516.
Oh, sorry.
Did you open 15 too?
Did you go XR 1515? Sorry, I couldn't remember which one I said after we left. So would you like me to go XR 1515?
No, are you all good?
That's all right. Yeah, I'm all good.
Okay. And yes, it's true. Can you see that this is negative? So yes, there's a negative ratio. The higher the interest rates, the less people will buy houses.
Yeah.
And remember, this is my Y variable. Okay? This is the one I want to predict. And I've just made a mental note now for me. It's what it puts in the heading is the Y variable. But I would typically change this and say interest rate. You always say by common understanding the X variable first, interest versus housing start. And I will typically go and add the access descriptions by, I know you guys are on Macs and I know you guys know how to get to it. And if you don't figure out how to get to it, I do it this way, access titles, and now I say and I'm clicking on that one. Okay. Oh man. Okay, for exams or assignment, you know that you need to format it nicely. So I'm not, unless you want me to show you what I mean by format nicely. Do you like?
You're talking about the colors in the background?
Yeah.
And just spacing it out and.
So right click.
Oh.
Yeah. Okay, let me do it. We've got time. So the full, solid full, I normally choose sort of color like that. And then this one, solid full, white.
Hey, Francois, on Excel, can you like, is there not, it's not related to this topic, but just in general life, where if you can put in like information of like amounts and stuff, and you just create, hey, I want to make a 20% profit margin with all this equipment I have, like how long it will take for me to make up the money back, and etc.
Yeah. Let
That's
me finish this one and I'll love to answer that one. I actually just did the Bus202 tutorial before, and that's where they do that a lot, the financial subject, which I'm sure you guys will either do. But yeah, I'll answer your precise question just now. Okay, so first of all, I now know all of this stuff. And as I recommended, let's go and do it through the actual add-in. So I click on data. You see, it's so quick that if you do 5 or 10 of these, you'll be so quick. It's not even a hassle. Regression. And all you need to really watch out for is that you always know which one you want to predict. In this particular one, we want to predict the housing starts, which is this one here. And we want to use the interest rate as the independent variable, or the one we want to use to predict. We included the labels. I can tick confidence limit, and I can tick, and I'm going to tick all of these, and then I'll go through it again. I can have it printed out, but I'll normally just check the plots. And okay, I'm going to put it into a new worksheet just because we know what we're doing anyway. Okay, so here's my summary statistics. I can now do all kinds of weird and wonderful things. I can have a 95% confidence limits, upper and lower limits. I can add other things that I predict. What did they ask here? What does the coefficients of the regression line tell you about the relationship? So the R square is the thing that you need to do. What does this tell me? 0.29. It says to me there's not a very strong relationship because it's lower than 0.5. Can you understand that? And now if I go and look at the actual plot, can you see that these dots are not that close to the line? Can you see that?
yeah.
Okay. At any rate, so, and we can also look at the probability, which is this p-value. And you can see the intercept is less than 0.025, but this is 0.1. So it's not the 0.95 level. This probability should be less than 0.05. And in one case it is, but in this case it isn't. So again, it tells me the relationship isn't that strong. And you can do the t-test as well, this t-stat. And I can't exactly now remember how you do it, but I'm sure you guys can read about that and do the t-test. But you won't need that at any rate. Do you understand how to do this now? And we can look at, again, at least the errors is normally distributed because this is sort of a straight line. Can you see it? I can check this one. This is the same graph as that we've done. Yeah, and it looks similar to me. It's sort of going down and so on. And we can look at this residual plot. And I don't see any patterns where this is wide and this is narrow. There's not a lot of data, so you don't see much, but it looks okay. I don't see any problems here. So yeah, I know the model fits and I'm happy with that. Okay. Are you happy with that, or do you want me? Have you guys done this now? Have you catch up and with me? Have you done these calculations and added this in? I do expect you to be able to interpret this one, these two, and maybe these four. Let me make it clear. I do expect you to be able to interpret this one. I do expect you to be able to interpret these two and know how to use these two. Oh yeah, and know how to interpret the p-value. What else is there? And the t-stat. Okay. The rest, take note, but not that important for now. Okay. Okay, Nicholas, ask me your question.
Oh yes, it was not to do with this thing, but
I know. So, but let's just quickly do it, and then we wrap up and we finish.
so let's say myself or someone in here starts a business and say, these are the 10 things we just bought to launch the business.
Yeah.
How do we calculate like how long it will take for these 10 items to be to make money back and making profit?
Okay, so what did you buy? What is the buy price?
Okay.
Just give an estimate. Say, would you? Okay, I mean the buy price, say $100.
Yeah.
Okay, I'll give you an example. My buy price is $25.
Yeah.
Okay, my sell price, because it includes installation, is $190. $190. And so it's called gross profit. For argument's sake, is, what is that? Equal this minus that. Okay. So number of items. So in this particular case, you can see I make my money back in the first instance, isn't it?
Yeah.
Okay. Number of items is 100. Okay. So my initial cost is equal. I bought so many of them at this price. So I've put in this much money.
Mm-hmm.
Okay, and then I can say, I would do it like this: item 1, 2, 3, 4, 5, 6, 7, 8, 9, say. And after I sold one item, my gross profit is equal 165. Okay.
And then, yeah.
And then if I sell my second item, is in total that times this one. Now I can quickly see. Now I must keep that one absolute. So press F4. Okay, so how many did I buy? 100. Okay. Okay, so now I can get my capital back, say here.
Oh, like that. Yeah.
So I need to sell 16 and then I'll get my money back.
Fair. Okay.
But I could also have done the calculation, and that is this. This divide by this should also be, 15.15. So after I sold 15 of them, now I can change the whole thing slightly by inserting a line here. And say, for instance, I can add in my labor.
Yeah.
So for each one that I install, it takes me about an hour. And say, for argument's sake, I want to charge myself out at $60. So the gross profit now becomes this.
Yeah, makes sense.
My labor. And now my whole calculation change. And I now got to sell 23.
And
But
the buy price?
I obviously get a payment. For everyone I install, I already got $60.
Yeah. So the buy price would include, let's say the scenario is I work in a cafe, so I sell coffee. So therefore, like a 20 gram of coffee beans is like what, 50 cents plus 200 mils of milk. Is it like that? Like one coffee, how much it costs?
Yeah. Okay. So for instance, if you say a coffee, so you'll have to break down. So milk, coffee, water, electricity,
and labor. And can take away containers or whatever it is.
Container.
Damn, there's actually a lot.
Yeah. So let's see, in a cup of coffee, what do you estimate is the cost of the actual coffee? Cents. Must be like 10 cents.
Yeah, let's say 10 cents.
And the milk is 10 cents, I guess.
Yep.
Sorry. Okay, let me make it 0.1 and 0.1. And the water 0.01, 0.02. Electricity. Well, I mean, you can do some calculations, like for instance, what is my monthly, say in my house case, say my monthly electricity is 200 and I sell, how many cups of coffee do you sell?
Let's say 200 a day or something.
200 times 20 is 400 for the month. Okay. So my electricity is equal that divided by that, which is 50 cents. And yeah, you know, whatever. But obviously you need to consider a couple of other things and say my coffee is only 20% of my turnover. The rest is something else. So you come up with an estimation, let's say 20 cents. I mean, you can physically go and measure it. You can calculate the electricity usage by looking at the amount of kilowatts used. You know, how long does it take you to boil a kettle and so on. You can actually calculate it if you want to. Again, your labor is, you look at your total labor is for, say, $2,000 for one person, and that's for 40 hours, 460 hours. So that's roughly this divided by that, works out, say, $12 an hour, which is probably a bad estimation. So let's make this $20 an hour, or let's make it 75. $26 an hour. That's probably not a bad estimation. So that's per hour, and to make a coffee is taking 5 minutes. So it's equal that divided by
12? No, 6.
12 if it takes 5 minutes. Yeah.
Oh yeah, 12, yeah.
2 cents. What is the container? That's probably 3 or 4 cents, is it?
Yeah, it'll be that.
Is this $2, or let's just see this calculation? Is that, why did you divide it by 12? No, okay, that's right. It's $2. The labor cost is $2. There's no doubt about it.
Because it's 12, yeah. Sorry.
So it takes you 5 minutes, so that's about $2. Okay, and the container is about what, 10 cents, 20 cents?
Yep, 20 cents probably, yeah.
0.2. So now we end up with a total cost. Okay, equal sum. Okay, and now you sell it for, what do you sell it? Sell price, what's the sell price?
Around here would be like $4, $4.50.
Okay.
That's in WA, but I don't know what's it like in Queensland.
Yeah, $4.50 is okay. I bought a coffee today. So your gross profit is that. Okay, and then you're back to the scenario. How many coffees must you sell to get back your money? Does that make sense?
Yep, makes sense now,
You
yeah.
probably just got to work through it like that. I just realized I'm still recording, I think. So let's stop recording. Okay, goodbye everybody that's watching the video.